Micturition. So what is micturition? So it's just a fancy name for, or aka for voiding, aka uresis, aka just urinating, peeing, right? So this is what micturition is. So how do you know when you need to micturate? Well, when your bladder is full, right? So you can feel when your bladder is full, and you're like, oh, okay, I better find a bathroom real quickly because again, it's full up. So this involves something called the micturition reflex, and I'll provide a little refresher on what reflexes are. So if you're here last semester, you remember during the neuroscience and neurology part, remember the patellar, aka the knee jerk reflex? Did you actually need to think about it? And if you took the lab, did thinking about it really help the reflex? And thinking about it or trying to interfere with the reflex or tensing up actually inhibits it. So what we have here is the patella down here, and you're hitting this quadriceps tendon or quadriceps ligament. I'm not getting into that debate. I don't care about the debate, but it's attaching the quadriceps. So what happens when you hit this part? It actually stretches this muscle a bit, and then you have something called spindle fibers. These are little receptor sensors that kind of detect the amount of stretch in the muscle. So this sends something to your spinal cord. It sends signals and action potentials. But the thing about this, it sends an instant once it interfaces with motor neurons here, the motor neurons send signals to contract this muscle. When you contract this muscle, this causes that knee-jerk reflex. Again, if you saw last semester and like especially those super responders and how they were like really kicking with these sensory the patellar reflex, again, they couldn't control it. Why? Because it's a reflex. And the thing about reflex is you don't need input from your cerebrum. You don't need input from your brain. Why? The sensory signals are going straight to your spinal cord without having to go up to your brain and going back via these motor neurons. No brain involved, and this is why reflexes are pretty fast compared to if you had to go all the way here, all the way up here into the cabeza, and then down here into the motor neuron. Okay, so here's your bladder down here. This is my simplified diagram because if you saw that previous beast of the diagram, it's pretty complicated. This is my simplified version right here. So what we have here is the urine. So here, building up in your bladder, all your ureters are carrying all of that. So the thing is, your bladder fills up. It starts to distend, it starts to add more pressure and also stretch out the walls of the bladder. So the thing is that on the walls of your bladder, you have something called stretch receptors. Again, instead of being like those protein receptors you have on cells, this is one of the few times we're talking about receptors in terms of cells or neurons that detect something. So a receptor is a special type of neuron that senses something. So these are sensing stretch via those mechanically gated ion channels, if you remember that. And then it's going to the spinal cord. Again, it's a reflex. So it's not going to go all the way up into the brain for this reflex. So what do these neurons do? Well, they actually activate parasympathetic nerves. So if you remember from last semester, remember like fight or flight and rest and digest. So parasympathetic is that rest and digest, but not only digestion, but also urination as well. So parasympathetic nerves, these are the ones involved in relaxation and taking it easy. So these parasympathetic nerves are actually going to open this muscle, and cause this muscle to relax. It's called the internal urethral sphincter. Hey, there's that word again. So remember, a sphincter is a ring of muscle. So again, if you have a ring of muscle and it contracts, it closes up. But if you cause it to relax, it opens up. So this is what this parasympathetic nerve is going to do. It's going to cause this internal urethral sphincter to relax, thus opening up this little passage in the bladder. So now urine can flow, but the thing is that just like your rectum, your bladder also has a double seal. There are more than one sphincters. So you have internal urethral sphincter. What's the opposite of internal? Again, just like muscles, if there's usually an opposite term, that other muscle probably exists. So the opposite of internal is external. So thank goodness you have a double seal for your bladder, right? Again, you don't want this thing opening up without control. So now what happens? And the other thing, okay, rewind a bit. So parasympathetic nerves activate or actually relax your internal urethral sphincter. But the thing about this micturition reflex, it also activates nerves that cause the muscles in the wall of their bladder to contract. So if it's contracting, remember, contraction always shortens the length of muscle. If you're shortening the length of the muscle surrounding your bladder, what's that going to do? It's going to try to make your bladder smaller, increasing the pressure on your bladder. So that's why the more your bladder fills up, the more you're kind of like, ooh, I feel more pressure down there, right? So it's not only just due to like feeling, since the sensation is going to your brain, but also due to this micturition reflex. Now, what's the thing here? So the funny thing is that it also, so how do you know when to go to the bathroom? Now you have these stretch receptors. So they're not only doing this reflex down here, so the reflex is this part right here, but it's also going to send signals along ascending pathways up into your brain, and your brain is going to interpret it, and it's going to think like, oh shoot, it feels pretty full down there. I better get to a bathroom really quickly. So what are you going to do? Well, you're going to go down to where it's safe to urinate, and then you can finally relax. So once you're in somewhere where you can finally release and micturate and void, then you're going to activate, again, you're going to send things down your spinal cord. And the thing is that you can also do voluntary contractions of your bladder. So this is what I'm showing here. Now you're actually making a decision, you're actually at the bathroom, and now you're going to send additional signals that help to contract the bladder. And again, this is why you're able to kind of give a little more oomph when you urinate, right? You're allowed to add a little more pressure when you're finally there to void. And you're also not only going to cause more contraction of the walls of your bladder, you're actually going to send signals like, okay, now it's safe, now I can release, now I can finally open that external urethral sphincter. So this external urethral sphincter, instead of being a reflex, is actually voluntary. And thank goodness for that. Imagine if you couldn't control your external urethral sphincter. As soon as this fills up, that's when it would go straight through. And that's why babies, they don't really have, and infants, they don't really have good control and cerebral control of their muscles yet. So this is why they're not really able to control this yet. But as you potty train them and they grow older, they learn to hold it in. Why? They're actually learning to how to control their external urethral sphincter. But if you don't have control, like the babies or neurodegenerative diseases or elderly people, if they start losing motor control of this external urethral sphincter, as soon as this fills up, what's that going to do? Activate the micturition reflex, and then boom, leakage.